Hi, I'm Domenic Ravita, Field CTO at MemSQL. Thanks for joining for another edition of the Community Conversation. Today we have Franck Leveneur, a DBA manager at Hulu. Frank, thanks for joining us.
Thank you. You're welcome.
So we'll start with a quick quiz, and just 4 quick questions. PSG or Olympique?
PSG, Olympique de Marseille? Good question. I like PSG because
Okay.
Mbappe is impressive.
Yeah. All right. Pinot Noir or Cabernet?
Cabernet, for sure.
Okay. VI or Emacs?
VI. That's VI.
All right.
I don't know what that is.
All right. NoSQL or SQL?
SQL.
SQL. All right. Great. Tell us more about yourself. You're a DBA manager at Hulu. Give us a little background on your experience and your hobbies.
Sure. Well, I'm a DBA manager at Hulu. I've been working there for about a year now. Prior to working at Hulu, I was working at WAG. Sorry. Yeah, I was at WAG. And I was working there as a database architect and a data service tech lead. So I started a data manager, a data engineering department to build a data warehouse. I've been in the database world for more than 20 years now. I've done a lot of database modeling, database optimization. I used to work on Microsoft SQL Server for about 12 years, and I shifted about 10 years ago to MySQL. And the main reason I shifted, I remember, was because I always wanted to work on a Mac. I was tired of working on Windows, and I was like, I hope one day I can work on a Mac for my work. And I saw MySQL. I was like, okay, that's a great opportunity, because it was, at the same time, Mac was shifting into being Unix. So that was a great opportunity for me. I really love what I do. I'm very passionate. I have a few hobbies. I love soccer. Those questions about PSG and Olympique de Marseille. I love wine. I was born in France. I've been here since 1993. So I've been in the US more than I've been in France. I just came back from actually France in July. I was lucky to be able to travel during this pandemic.
Mm-hmm.
And I took my kids to see Bordeaux and Saint-Emilion to give them a little wine tasting. They are 14 and 16, so they were all worried that they were going to drink some alcohol. But I was like, don't worry, it's France, okay. Yeah, that's about me.
That's terrific. So with such a varied career, you did some front-end development work and now you're a DBA manager. How did you move from the front-end development to the back-end or data architect DBA manager role?
Yes. So when I started working back in '94, I started as an HTML programmer. I always wanted to be in computer, but I didn't know exactly what. I tried multimedia, but it was not really for me because I'm not good with colors and I'm not an artist. But I wanted to do something in computer. And I remember I was working as an intern for a company, and the guy showed me AOL, and I was like, wow, this is amazing, right? And I was like, this is the future. And I said, this is the future. And then I just jumped on HTML, learning it. And then I got hired to work on the first Lexus website. And then we worked on other projects. And what we started doing is building dynamic content, right? Instead of writing each HTML pages, we started generating those pages dynamically with database. And I looked at it, I was like, wow, this is really cool. It makes sense to generate content dynamically. So that's how I got, because I was tired of writing HTML and JavaScript. Right? That's why it's shifted. I was to database and learn Microsoft SQL, two classes in database modeling, And then I worked after that for a company called GenX, where we also built a Acura website. And then from then on, I stayed in database and learn about different technologies. Always open to learn new database technologies. And recently, when I was working at ZipRecruiter, I was approached by UCLA Anderson to teach, and there was no curriculum, so I had to build it. And basically, it was about data management. So, I challenged myself, say, okay, I'll do it. So I had to learn a lot, like to shift a little bit away from DBA world, more into data engineering world. So I learned, about online pipeline, Fivetran, Aluma, and data engineering, Hadoop, and all these, and Kafka, and all these technology that are involved in big data. So this was a great opportunity for me to really expand my knowledge and have a better understanding of what companies are doing out there. The database is always the receiving ends, or where the data source is born with the OLTP. But then I didn't know that there were so many other data sources that companies need to pull data from, right? And then IoT was also, it's also happening, machine learning. And so it was really a great way to expose myself to all these technologies.
Mm-hmm. Terrific. So you've seen a lot of different technologies on the front end to the back end. When you're looking at new technologies, what's your approach to evaluate them?
I always, my favorite company is Apple. Not because I use them, but because for what they do, what they are. For me, they are a creative at its essence. They create not only hardware, but there's beauty around it. Their website, their marketing, everything fits together. And for example, when I discovered MemSQL at Strata, I saw it as a great technology. And the first thing I did after that is I went on MemSQL website. And the website reflected, right, the technology. Like, it was a well-designed, well-thought-out website. It really put the product, in the front, and everything made sense to me. Whereas I've seen other technology, and I've been to their website, and their website, sucked, basically. No effort was put into presenting their product. So if you're a customer and you go to a website and you see a website that is not attractive, it kind of tells you something about the product, right? It's like, okay, what is this? When a website is well designed and it reflects, it really, the marketing behind it and the way document is presented and organized, you can tell that people are putting time into it. They are passionate about their product, right? And they like it. So for me, that's important.
Mm-hmm. Yeah, design is important. Well, you appreciate the design on the front end and the back end. And when it comes to database workloads, design of your queries and how you structure data is important. There's an architect in the late 19th century, Louis Sullivan, who was the first American modern architect for skyscrapers, and he coined this term that form follows function. And in our industry, that's been taken on and used as a guide for data structures and data processing. In your view, when you're evaluating technologies, I guess my follow-up question is, when you're looking at workloads, how do you evaluate them for the appropriate technology for the type of database workload?
Yeah, it's, there's no database out there that can do everything, right? Some databases are very good at what they do, right? If you take, for example, MySQL, right, it's great for OLTP. But if you go into analytics and you want to build reports, and you have hundreds of millions of rows and you want high concurrency, that's going to be challenging. MySQL, Aurora, MariaDB, I'm sorry, but I haven't seen anything right now that tells me this solution can scale to reporting. And yeah, it will scale, but you're going to spend so much in hardware and maintenance. Is it really cost saving? No. MemSQL, on the other hand, is built for analytics, right? It uses two different database engine, memory and column store. And when you run a query, when you do a count on a billion row table and you get the result in less than 1 second or half a second or even faster, that tells you that this database is built for that, right? Now, I've seen question in the forum, MemSQL Forum, can I build an OLTP database in MemSQL? Yes, you can. It's possible, right? You could build it in Snowflake or anything, but you won't have referential integrity, right? So how do you implement that? Do you do it at the application level? What's the burden in doing that where at the database it's built in, right? So maybe it's better to use a database that has referential integrity because you want to make sure your data source is clean, right? Because that's what's going to be driving your business, and you don't want bad data into your analytics. Then after you can migrate that data into a reporting solution or a fast data warehouse like MemSQL, in order to build reporting, or Snowflake. So that's, for me, it's, you need to look at long term. When you build something, right, and that's something I see many times with developers, they'll build a table, oh, I don't need an index here, the query is very fast. I said, yes, but the database is going to grow, and you have to think that your table is going to be 10 times, 100 times bigger, and you're going to have 10 times, 100 times more people querying that table. Is your table still going to be fast? So your database can evolve also, I would say, horizontally, where the structure of your data, the structure of the table can change. You can add new column, you need the text field here, et cetera, et cetera. So, building, optimizing your database from the get-go is important. Choosing the right technology is also important, because migrating a database technology to another is expensive. Migration, you're always going to run into issues. There's always a little bit of differences between the two technology, things that you can do in Microsoft, in MySQL that you cannot do in the other. Right? So it's, it's important to spend time upfront and step back instead of always trying to build something quickly to be in market. Because if you build something quickly in market and your database cannot scale, you're going to basically have a lot of users that are not going to come back to your product, right? So I think that's pretty important.
Mm-hmm. And so you've mentioned a couple of databases, SQL Server, Aurora, Snowflake, MemSQL. When and how did you first discover MemSQL?
I was at Strata back when I was working at Rubicon Project. So that's around maybe 2012, 2011. Mm-hmm. And I was just walking on the floor, going from booth to booth. And I stumbled upon Eric, who was the CEO at this time. And he showed me a demo of MemSQL. And I was really impressed with the technology. For me, letting the database do its work to shard the data for you, right? Being able to add nodes and separating the compute from with the aggregators where you can manage concurrency, for me was a smart solution, and being able to scale both, right? So if you could have a high concurrency growth and your data doesn't grow that much, so you can scale just the aggregators, right? Mm-hmm. Versus the opposite, where it's your data that grows, right? And you need to scale basically your leaf node. So I was impressed with that, and I tried to introduce after that MemSQL to Rubicon project, who is a ad serving company, and at that time I don't think they were ready to buy a new technology, but they were still impressed with what MemSQL could do.
Okay, so tell me about the first time that you found an opportunity to use MemSQL, and tell us about the requirements of that project.
The first opportunity I had to use MemSQL was to implement it into a company. When I was working at WAG. I was hired as a DBA to take over their database. Like many startup companies, the database was overloaded because developers spend their time creating a lot of code, and they didn't pay attention to the architecture too much, and they were basically shuffling everything into MySQL and running very disruptive queries. And the database was running on the AWS ODS 5.6, and the database would crash every day. So when I was hired, the first thing I had to do was to tune MySQL, and then after that, optimize the queries. And once I get some stability in the database, then I started moving a lot of read query out of the primary into the replicas. And then after that, when they realized what I had done and that the database was much performant and stable, I told them, okay, we need to move some queries out of MySQL because they are not meant to be there. MySQL is not really built for that. So I introduced MemSQL. We moved out the audit table, which was about more than 1 billion rows. So it was really, first of all, it was taking a lot of space, right? Some memories. They were running other queries on it that will impact, on the replicas, which could create some lag. So it was not efficient. It didn't need to be there. And we moved that to MemSQL, and basically with using the column store architecture, we compressed that table down to maybe 30 gig, and it used to be 300 gig, something like this. So right there, we saved a lot of space. We moved a lot of counts that they are doing on MySQL in MemSQL. And what started happening is the engineer realized that MemSQL was really fast. And it was like MySQL. So they started asking me if we could put some table into MemSQL using the memory engine. So we did that, and they started using it as almost like a Redis server, where they would create a table and use it as a key pair value table and just query it.
Like a key value store that fetches for lookups.
Yeah, exactly. So yeah, using MemSQL at work was a big success. More and more engineers realized what we were doing. They started asking me if they could use it, for caching purpose, the cache table. They were for counts and analytics. So they started understanding, why I introduced it to WAG and the possibilities that we could achieve with MemSQL. So it was a very good project.
So two questions, why was the key value lookup, why was the caching needed? I mean, what was the sort of the business scenario that was a use case to be solved? And then secondly, why was the lag time a problem for the WAG scenario? And maybe if you can explain it in maybe the user experience for the customer's point of view as to what the impact was for both of those.
Yes. So the challenge with MySQL is, especially when you use replicas, is lag, right? Replication lag can be critical because if you insert a value into your primary server, and you query the replica and the value is not there, you're going to get an error, right? You're going to get stale data. So this is challenging. I mean, it works for some type of data that you want to access, but for like, write and read almost immediately, it's not possible. So with MemSQL, there's no replication. It's a cluster. Data gets sharded. You write, you read, the data is there. And that was the main reason why they started using MemSQL for, key value store to cache, for example, attributes, user attributes, values that they wanted to access. We were also, as you know, WAG is a dog walking application. So we're using geospatial data extensively. So being able to track in real time where some dog walker were, where the dog owner is, etc. That's important. And MemSQL supports geospatial data type, and we could run query and generate a response very, very quickly in milliseconds. So our application latency really improved, because we had some drag when we were using MySQL. When we shifted some of the services, API services to MemSQL, we saw a dramatically improvement.
Mm-hmm. And you mentioned, MemSQL does, automatic sharding in a way that you specify with a shard key. But you mentioned that with AWS RDS for MySQL, you don't get that sharding benefit, but there is distributed data there. Explain a little bit for those that are unfamiliar, maybe with how RDS distributes data versus how MemSQL distributes data.
Yeah, so MySQL replication is basically distribute your transaction where you write a record into one server and then it gets replicated to other server, right? And that replication time is called, the lag, right? So if your lag is 0, great, right? There's no lag, your data is written here, and then you can set it in there. But as replica gets busier and busier, the lag can increase because the replication mechanism depends on the resources on the replica. So the more usage, the more CPU usage, the more network usage, the more tables that are being used, right? Create contention, then replication starts having trouble to replicate the data. On MemSQL, there's no replication, right? It's you write and then it gets committed to all the left node, and that's it. The data is there, right? Yeah, there's no dependency on moving a data from one replica to another. And that's true for if you have 2 leaf node or if you have 60 leaf node. At Hulu, we use MemSQL to ingest events and for some particular processes, and we ingest about 100,000 events per second, right? And these get basically automatically distributed to all the leaf nodes. And then at the same time, you can query that data. That's the big difference also between MemSQL and MySQL is there's no locking mechanism in place. Where if you try to do that on MySQL, if you're inserting heavily on the table and you try to do counts, because when you do a count, you're going to be scanning. Mm-hmm. Even if you have an index, you still have to scan the index and to get the results. Mm-hmm. On the MemSQL side, because you're using the column store, you're just looking at one row. Mm-hmm. Versus MySQL, you're looking at rows, right? And that's the difference. It's very fast. So replication is great. You can have lots of replicas, right? You can scale your reads, but if you have too much workload on it, then you can face basically start having some lag, which can create issues for your reads. There are databases out there like Aura that provide 0 lag latency. It's a great technology. but their replicas are also dependable on certain load. If you hammer those replicas, it could affect also the others. It's also not meant for everything. I know Aura is trying to push for analytics on their server using parallel query, etc. But for me, that's really patching, right? It's not a data warehouse. Aura is not a data warehouse. It was not built for this because the engine behind is InnoDB. It uses memory, and it's built for LTP. It's not built for analytics.
Mm-hmm. And so have you used AWS RedShift for some analytics, and how would you compare
Yes.
that with MemSQL for various use cases?
Yeah, so when I was working at ZipRecruiter, we were using RedShift. And the problem with that is, and that's a problem in a lot of companies, is they don't understand the different world. There's OLTP world and there's OLAP world. And they are really different, right? And their purpose are different. But a lot of companies, what they do is they take the OLTP world, meaning the tables, and they move them to the data warehouse. And they think that the queries are going to be much faster, which is not possible because you're going to be joining lots of tables, and joins are always expensive. You're looking also at large table. And then they think that, having 10, 20, 50 users querying those tables is not going to create issues. On Redshift, it creates issues because there's a queuing mechanism for your query. So it creates, you're basically multi-concurrency bound, right? As your multi-concurrency increase, your queuing get filled up, and those queries takes longer and longer to run, right? So it's not surprising to see queries taking a minute, 2 minutes, 3 minutes, even more, right? On the MemSQL side, there's no such thing. You can scale your high concurrency by adding aggregators. And because it's really built for analytics, because your data is really sharded into all your NIF nodes, because also the column store architecture is really optimized, and also because you can use memory, you can really scale your data warehouse very efficiently. So I've seen this, and also one big issue that I've seen over and over in startup and companies is that they don't use dimensional modeling, meaning building fact and dimension table, right? There's a man called Kimball who spent his life, right, producing lots of work in terms of explaining why you need to do dimensional modeling into your warehouse, why you need to transform data, how you can enrich also your data and your dimension so that you have more valuable reports, so that you don't have to join and do crazy queries. When I was working at WAG, we actually shown a difference between a query in Periscope that joins OLTP table. This is a query in data warehouse, right? And it was basically 5 to 6 joins in OLTP versus 2 or 3, right? And the query is very simple, right? And that's the goal of reporting. The goal of reporting is to build very easy, very efficient query, and to make the join between table and the group by and the counts very fast, and also multi-concurrency, compatible, where a lot of people can query and you get fast result. So if you can do that, build dimensional table and fact table, and you have a database that is very fast, that can scale, that support multi-concurrency, you're in heaven. You can scale. There's no limit.
Yeah, it goes back to Lewis Sullivan, where form follows function. If you're going to do these types of queries for this kind of data, then the structure of that, even in a fast data warehouse or column store like MemSQL, your schema design matters, right?
Definitely. I mean, yes, definitely. And that's a lot of, that's a lot of problems. I mean, or a lot of, I've seen this over and over in many companies. And actually, you have businesses and companies out there like Periscope and Looker who take advantage of that, right? They say, yes, move your data into Redshift or Snowflake, and we'll put Looker on top, and your query will be fast. Yes, but if you remove that, underneath, you're still using an OLTP table. So if you want one day to switch and use a different reporting solution, I mean, you're going to have slow queries. So it's not, it's, for me, I always think that it's important to spend some time thinking and doing some architecture for the long run, right? Because as a company, you're there for the long run, and it's important to have a good foundation. And it's like a house, right? Mm-hmm. You need a good foundation, a good structure, then you can build. But if your foundation is patched and there's holes in, I mean, who knows? The first earthquake and your house is on the ground.
Right. Yeah, it's, would you say that there's sort of a need for a renaissance or revisiting of data literacy, but not in the sense of how data scientists talk about this, but more in like a data modeling literacy or data schema literacy for front-end application developers? You've been a front-end application developer, and I've worked on the back end for quite a while, so you can see it from both sides. Do you feel like we're at a moment now where front-end developers, application developers are starting to gain an appreciation for data modeling literacy, maybe partly because they've had enough years experience with NoSQL approaches to some of these problems?
Yes, I mean, definitely. And actually, that's what I teach to my students at UCLA Anderson. They do take a class about modeling before my class, but we cover dimensional modeling. And it's interesting because they have trouble understanding the purpose at the beginning when I try to explain them, the dimension and the fact, because it's challenging. Creating a fact table and creating its dimensions is not easy, right? Because you have to look at the fact that you want to report on. You have to identify those, and you have to get the data to build those table. And dimension also can, you have changing dimension, and that's challenging to build. But once it's built and everything is automated with scripts, it's powerful because you can really build queries efficiently. So definitely, all the engineers, all the developers, they need to read about database modeling and understand why it's there. It's very important. Data integrity is important. I read a lot of people saying that foreign key, slows down the database, especially on MySQL. I never had that issue. And honestly, if you have in your OLTP system you have a billion row table, something is wrong, right? You don't need a billion row table in your OLTP system. You can always archive data, right? Or move that data somewhere else and go query it. More and more people now are moving away from like a monolithic application and more into microservices. So it's important to look at the big picture. In the end, you want peace of mind. You don't want to be waking up at 2 o'clock in the morning trying to fix issue or your database cannot scale. That's the worst scenario. I've been through this. It's irritating, right? You're sleeping and at 2 o'clock you need to get up and there's an alert because, I don't know, something is not right. So, yeah, I mean, modeling, crucial. And also the data warehouse, if you want to do reporting, I think it's important to understand what's a data warehouse, what's our dimension and fact, how to model this, right? and then build around that. There's a lot of tools out there, like dbt, for example, which is getting a lot of traction that does that, right? That takes a data source and build fact and dimension for you so that you can run reports on it.
Mm-hmm. Yeah, and I want to go back to something you mentioned earlier around the latency of query response time. And when you were speaking about RedShift, you mentioned different response times. And for some use cases, you need a predictable response time that has a low variance across multiple queries. It's fairly consistent in that response time, rather than being a few milliseconds here and 200 milliseconds the next time, and unpredictable in how much time. I mean, for the use cases that you used MemSQL with, so what's the importance of the predictability of the response time?
I mean, response time is everything, right? If you go on the internet, web pages response time, after 3 seconds, the user is gone, right? Yeah. I think the internet has made us impatient, right? We are not patient anymore. We want things fast. I mean, it was okay when we were using a 14 baud modem and it would take 30 seconds to load a HTML page. Yeah. But that's gone. Now with the internet, cable, I mean, these pages loads fast. So we have expectation, right? We need things quickly. It's the same thing for a report. Who wants to wait 30 seconds for a report to come back, right? You're looking at data, you're doing analytics. You want that report to come quickly, right? Mm-hmm. And if you have 10 users or 20 users querying that database, you want the same response time. You don't want to be telling someone, well, you cannot query now because I'm doing this, right? And the guy said, well, I have to do my analytics. I said, yeah, but I'm querying. I'm building a report for the CEO. It's very important. You cannot touch the data right now, right? So this tells me, okay, you're not using the right technology, right? You're limiting yourself. And I've seen this with RedShift. Like at ZipRecruiter, when we were running an end-of-month report, it was hands-off, right? Mm-hmm. Because those reports takes a long time. You don't want to be touching, you don't want anybody to touching and adding some load on the database. And they had to constantly basically change the configuration and augment the capacity because, of course, that data is growing because it's growing from the OLTP side and they don't transform that data, right? So you're creating a lot of constraint on your user, right? And the user gets frustrated because they cannot do their job. Mm-hmm. It's I don't know. It's a decision that has to be taken at a higher level, but they have to understand why, right? Why does it make sense what is a data warehouse? Why does it make sense to build one, right? And what's the right technology to use for a data warehouse? Because, you could build a data warehouse in MySQL. You could. Nothing prevents you to do that.
Right.
But is it going to scale? Is it going to be fast? Is it going to allow multi-concurrency? How many can it support billions of rows, right? With 250 gig of RAM? I don't think so, right?
Right. So you've built customer-facing SaaS applications with mobile interfaces like WAG, and now at Hulu, there's probably internal customers for some of the applications that your databases support. For HTAP, for hybrid transaction analytic processing, how does this help simplify providing the transactional speed and volume while also doing, basically what amounts to continuous analytics or operational analytics against that fast-moving data? From a consumer SaaS point of view, they're doing small, what you might characterize as OLTP kinds of transactions, but then they want to look up their history, or they want to look at, maybe it's an account that has many users and it's a broad aggregation, but they don't want the data from yesterday's report or an hour ago. They want to know it instantaneously because, as you said, we're spoiled with the internet with the instant answers. Mm-hmm. So how does how does an HTAP database that's distributed native like MemSQL help simplify solving that problem?
Well, MemSQL is a different beast. You have multiple nodes that take advantage also of the CPUs. Your data gets sharded and distributed across all those different partitions. It's important to mention that choosing your distribution key, right, when you build your table is important, because that's going to partition your data properly. You can have a data skewing, which means some nodes are working more than others, and that's something you don't want, right? You want to distribute your data evenly so that you distribute the load evenly, right? So once you have that, then you can scale, as much as you want. All you have to do is add a node, and then you repartition. And the database will automatically repartition your data using the key, and it knows how to redistribute everything. MemSQL has also the enterprise, how do you call it, where you can replicate your data. Like you could shut down a node, and you could still be able to serve your query. So it uses more space, but it also provides high availability, right? And that's great when you do maintenance. And we actually did that at WAG, where I think we were using a 4 nodes cluster, and we had to basically take down one node, to upgrade it, and then bring it back, take down another one, upgrade it. And then we had 2 aggregators. So we took down one aggregator, upgraded it, and at the end, we upgraded the last one. So we had 0 downtime, we had 0 transaction loss, nothing. And that was pretty amazing, right? Trying to do that with MySQL is going to be very challenging, right? To promote a replica to a master, you're going to have downtime. Even Aurora has a failover takes 30 seconds. During that time, you're going to have a loss of transaction. Nothing is going to be able to write anywhere. Not with MemSQL, right? It's really if you cannot have downtime, it's MemSQL I would say is the way to go for that. But you need to really pay attention to what I was mentioning earlier, is to make sure you choose the proper key for partitioning. And also you have to make some decision between row or column store. And it's interesting. What I really love also about MemSQL and its team, is they listen to the user. A lot of people were realized that, okay, the memory, we're limited in memory, right? Because if you use more memory, the license is more expensive. So they're trying to find a solution. The user was trying to find a solution to use column store the more, right? The most. And so they had this concept of hot and cold data, which I've used, where you keep your 1 day worth of data in memory, and then the rest you move it into your column store architecture, right? But now MemSQL is able to compress row store table in half, right? The compression is much greater, which allow you to store more data, right? Which basically diminish the cost. And then column store could not have a secondary index. Now it can. So I like that they are working on both ends. That's, I think, very important. And also been using stored procedure, and they are very, very fast and very efficient. So that's, for me, MemSQL is a really mature, modern database technology. It can do a lot, in terms of fast ingestion, multi-concurrency, super fast analytical query. I haven't seen anything like this right now in other database technology. Yes, there's Snowflake. It's a great data warehouse, but if you have to have results within milliseconds, you're not going to get that. If you have multi-concurrency and you need a result in milliseconds, you're not going to have that. With MemSQL, you can get that. And trust me, once you get used to fast speed, right, you don't want to get it. You cannot live without it. it's really hard to have something that is fast and say, you know what, I'm going to go for slow.
Right. Speed is addictive.
Yeah, it is. It is.
And I'd say simplicity too. Once you find a simpler approach, there's no need to start with a more complex. What you described earlier in terms of secondary indexes on column store and greater compression in row store, those are the incremental improvements we're making on our journey to what we call SingleStore, where you can run OLTP type of workloads on the column store, and eventually our SingleStore, our column store is becoming the SingleStore, such that it will be the default type. You'll still have row store if you have for the use cases. Certain edge cases would require that, but the goal is for the majority of these to be handled, and that in the SingleStore approach, and that greatly simplifies the upfront design choice. There's still design choices to make about schema, obviously, like you mentioned, and dimensions and facts. But in terms of the storage choice table type, that will be greatly simplified.
Yeah, and it's I want to come back to what I was talking about earlier, about schema design and modeling, etc. Because I often see in MemSQL forums question about which key should I choose for my table? Which one makes sense? And it can be challenging. And I think educating engineers on that, I like MemSQL documentation because you have example, right, at the end, and that's very helpful, right? And having tutorials or code that you can download. I know in Helios, the cloud, you can load data and you can run queries, right? You can immediately, as soon as your cluster is set up, you can start using it and load data using the pipeline, right? And I think that's great to basically provide tutorial to the user so that they can immediately get to have a feeling about the database and what it can do. And for me, that was also something that really impressed me at the beginning with MemSQL, is being able to ingest from S3, from Kafka, right, by just creating a pipeline using SQL code. I think that was really smart to do that, to have that built into SQL, being able to stop your pipeline, being able to test your pipeline, to query it and see what's being ingested, because it's so much work. I mean, before you had to write Python script to go get that data. Now you just create a pipeline in SQL, you point to your S3 bucket, you provide your access key and secret key, and boom, data get ingested automatically. I mean, that's pretty crazy.
Yeah. So what, for the community, MemSQL community members listening who are maybe getting started with MemSQL, and they may be coming from different backgrounds of using Elasticache, Redis, MySQL, Oracle, AWS type databases, what would be a few tips and recommendations that you would share with new community users who are first starting out with MemSQL?
I would say, download it and install it. And actually, I was thinking about that this morning. I think something that also MemSQL did that is great is to create MemSQL cluster in a box, where you can install it on one machine and still create a cluster, right? So you get to see within one box, for example, one EC2 instance, you can install it and then have a cluster where it's using different ports, right? And then it's, if you have multi-CPUs, then it's going to use all those different CPUs. So you don't have to have 3 EC2 instances, which can be expensive for some company, right? The cluster in the box, I think, is a great solution because that allows a lot of people to get their hand on MemSQL and use it. The Docker also version is also very useful for developers. So I would say, download it, explore, load data, ingest, create a AWS account, put some data into S3, and then just dump data there and ingest that into MemSQL and see the magic happen. Because it's pretty amazing to see that you don't need to do anything. That when data gets inserted into S3, it gets ingested automatically. And if you have experience with Kafka, you can set up Kafka and then plug MemSQL to Kafka, HDS also, Azure. I mean, it's pretty incredible, all the different pipeline that MemSQL supports. And also being able to transform data on the fly using transform before it gets actually inserted into a table or a stored procedure. That's also pretty cool. And I've done that at WAG. I wanted to basically, I was parsing the bin logs from MySQL and trying to ingest that directly into MemSQL, into a store procedure that will transform, the bin log into actually updates and inserts, so that you can basically replicate data between the two normals in real time. So that was the idea I was trying to, a project that I was trying to achieve when I was at WAG, because we had a walk table, we tracked all the walks, and I wanted to replicate that to MemSQL in real time to be able to count and query that table. So there's a lot of things you can do. If you love creating and coding, I think with MemSQL, there's a lot that can be done, especially with the store procedures and functions, and it's really good.
Right, terrific.
So yeah, it's I'm excited to see what MemSQL come up with next. I'm currently using the latest version, 5.1. I like the fact that they have
7.1.
7.1, yeah. And they have improved the variables in store procedures, where you can do what you do in SQL, where you select in two variables. That's a big improvement, because I use that extensively in store procedure in MySQL also. So I think just store procedure to transform data to do what DBT is doing, right? That could be also something very cool to be able to transform as your data arrives, build your fact and dimension table very quickly.
Right. Well, Franck, thanks for sharing your insights and experience with the community. You've worked across a lot of different database technologies and on the front end and the back end. So I think the community appreciates your unique perspective and experience. And we look forward to innovating together with you as you continue to use MemSQL. So thanks again for your time.
You're welcome.